Well, hey everybody, how are we doing? We have finished chapter 4. We are moving on to chapter 5, which is now starting to really break down this formula for linear equations that y equals mx plus b. We're starting to get in depth on what each part of this means. And so what are we starting off with in 5.1? Rate of change, slope. If you think about this, because most of you that are now in Algebra 1, since this is high school, these are going to be all using this equation, y equals mx plus b. And we're dealing with slope today. Slope, also known as the rate of change. And we're going to learn how do we calculate it, how do we use it, and all of that fun stuff today, okay? So let's start off with, well, what exactly is a rate of change? So a rate of change is showing a relationship between two changing quantities. Notice how our variables in all these equations now we're having has two variables. It is that change between the x's and y's. And we're analyzing that change, and from that, we can be able to come up with a slope. Every linear equation has a slope. It's either positive, it's negative, it could be 0, or it could be undefined, depending on what turns out from our investigation of this relationship that they have. A few different ways to calculate this here, okay? So rate of change, slope, or m. It's all part of this equation there. It's what's being multiplied by your independent variable. What it really is, it's the change in the dependence, which is your change in y's, divided by the change in the independent variables. So far, what we were really looking at in chapter 4 was our change in our x's were always 1. And then we looked at our change in the y's and we said, oh, there's our rate of change. It's not always the case. They don't always change in that same quantity. So when they don't, we have a formula to be able to calculate it, okay? They can give it to us in a few ways. They can give us two coordinates like from a table. We could also get coordinates as if they actually gave us points. Okay. We could also do it. So this is the formula for that. We have y2 minus y1, or the y coordinate of the second point minus the y coordinate of the first point, divided by the x coordinate of the second point minus the x coordinate of the first point. And we'll get an answer that we can reduce, and there's our slope. We'll also have rise over run. You know, if we're looking at a graph, you can determine, well, from one point on a graph to the next, how many up did we go? How many to the right did we go? And we set that up as a fraction. We reduce it, and that's our slope. Let's see how these work. Okay, let's take a look at example 1 over here. So example 1 is giving it to us in a table. So we should know that in a table, we have what? These are basically, guys, a bunch of ordered pairs. Okay, a bunch of ordered pairs. We have to determine what is the difference when we look at a chart like this. How are our x's changing? Our x's here are changing by 1, and then it changes by 1, and then it changes by 1. Notice they're all the same. How are the x's changing here? Okay, so you take 520 and you subtract 260, and we end up with, oh, it went up by, from here to here, it went up by 260. And then test it again. 780 minus 520 is 260. And then you do it again, and you'll notice that this is changing by about 260 each time. Right? So if you look at our first formula, we say, well, what is the change in the dependent variable? Our y's, this would be the y's here. These are our dependent. This is our independent. So we're taking the change in y divided by the change in x. The change in your dependent divided by the change of your independent. So you take 260 divided by 1. Our slope is 260. This is what we were basically doing all through chapter 4. We always had these nice, it was perfect problems. The x is always increased by 1. Okay, what happens if they give us random numbers somewhere in there? What if they don't give them to us in order? Or a missing point somewhere along the way? How would we find that? Well, that's what this second equation is for here. Okay, we have the equation m equals y2 minus y1 divided by x2 minus x1. How do we set this up? This is how I want every single student to set this up in my class. You're going to make a big division bar, and then you put 2 minus signs inside so that we can just fill in this equation. Okay? If we learn the equation, then we're not blindly memorizing things. Okay? So now to fill in our equation, we need to start to do different things. Nothing wants to cooperate with colors. All right, so to fill in our equation, we are going to take 1 point. I don't care which point it is, guys. It really doesn't matter. So take 1 point. We know that the y, look, here's one coordinate. They stacked on top of each other. This coordinate is stacked on top of each other. Take one coordinate, put your y on the top, and then put your x right below it. Take the next coordinate, put your y on the top, put your x right below it. Now notice we have subtraction here. Subtraction is the hardest thing we do when we're trying to learn algebra, especially if you're not good with number theory, right? So we have this blast from the past. Keep the first number the same, change this to a plus, change that to a negative, which doesn't even help us in that case, right? Keep, change, change. All right, so now we have -2 plus 0. Well, -2 plus 0 is just -2. And then we have 3 plus a +1. That's 4. Now, if we go to reduce this, right, because this does reduce, -2 or 2 goes into 2 once, 2 goes into 4 2 times, and because it's a negative divided by a positive, it stays negative. So there is your slope there. Okay? As you continue to move on, here's another example. So let's you guys pause this video and try and solve it. See what happens. All right. So again, we want our equation. Our equation is that y2 minus y1 divided by x2 minus x1. And our goal was that we are supposed to do it the same way every time so we learn a pattern. A big division bar, 2 minus signs. Take a point. It doesn't matter which one. Here, -3. This is our y, -3. Here's our x, goes right below it. We've used this one. Now we got to use this one. The y is a -3. The x is 4. Now we're going to keep this, change it to a plus, change this sign. Keep, change, change. And we want to evaluate now. -3 plus 3 is 0. -4 plus a -4 is a -8. And here's a cool thing. Some of you might look at this and say, uh-oh, I did something wrong. What happens when we reduce that? 0 divided by 8. Well, anything divided by 8 or by 0 is 0. You have a slope of 0. It's okay to have a slope of 0, guys. There's nothing wrong with that. That means you have the equation, or it's going to be a horizontal line, because think of a flat line. There's no slope to that. Put a ball on the floor. It shouldn't roll anywhere. There's no slope. All right, not too bad. Let's start to look at the third thing. Well, how do we find it off of graphs? Well, that's why we have this rise over run here. Okay, so rise over run is determining for us. We want to know from one point on the graph, using only right movements, meaning we can only go up and down or left and right. We're going to create a right triangle. We need to go from one point to the next point. Okay, so we start here because we read graphs from left to right. Here's the first point we're looking at. We need to go, well, how many units up do we need to go so that we can connect to this point with a right line? Notice the marks on the graph help us form that right angle. So we need to go up. Let's see, 1, 2, 3, 4. So we're going up 4 units. And then we have to go to the right 1, 2, 3. So we went to the right 3 units. This is what we have to remember when we do these graphing, okay? Anytime we're trying to find rise over run, if you go up, it's considered a positive movement. If you go to the right, it's considered a positive movement. If you go down, it's considered negative. If you have to go to the left, it's considered negative. And we're going to form a fraction out of this, right? We have our rise, the up and down movement, that was 4, and it means positive, so plus positive 4. And then our denominator represents the run, or the left or right movement. In this case, we had to go to the right, so that's a positive. And we look to ourselves, hey, m is equal to 4 over 3. Does that reduce? No, it doesn't. So that is your final slope. This one's a tricky one. Okay, very tricky one. I gave you an example of positive slope. I'm going to give you an example of our 2 very odd exceptions to this rule. Think about this, okay? We want to go from one point to the next. So rise over run. Did I have to go up or down at all to go to this next point? No, I didn't. So I did not go up or down. That's 0. And I had to go what? 1, 2, 3 units right only. Remember this? 0 divided by 3 is 0, just like our other example. So yeah, our m is going to be equal to 0. Notice this line here, right? This is a horizontal line. It's flat. Its slope is 0. There is no change in that line. It's like a floor, nice and flat. If you put a ball on it, it's not rolling uphill. It's not rolling downhill. It's flat. It shouldn't move. Look at the last one. Oh, wow. Again, another special case. We want to look at this. Okay, we want to go from this point to this point. We can only go left or right movements. So we always try to start with the up and down movement first. To go from this point to this point, how many movements up do we need to go? Okay, we're going 1, 2, 3. We went 3 units up. That's our numerator. 3. Did we have to go left or right at all? Because the denominator is our left or right movement. Notice we went straight up and we hit the point. There's no left or right movements. So left or right is a 0. Now this is a very special case here. This is a vertical line. Okay, a vertical line. Kind of like our vertical line test from the last chapter. When we reduce this, what do we get? What happens? So if you put in your calculator 3 divided by 0, you're going to get an error. It'll give you an error sign. This means that your slope is undefined. Undefined. And we'll just abbreviate it, UND, for undefined. Okay? I want to show you this. There's a trick to this that you can see. So we can see how slope works. It's my little friend called Mr. Slope. Mr. Slope is a very interesting character who gives us a lot of answers when it comes to being able to determine what our slope is supposed to be for certain shapes. And I like to give him hair because no one wants to be bald, right? Here's Mr. Slope. So do you see how this line here is like, it's a positive line? This slope of this line is positive. Think of it as, I'll arch his eyebrows. I'll give him even more manicured eyebrows here so we can see it even better. There we go. So there is Mr. Slope. So here, see this type of line. Whenever you have a line that's in this direction, like this example was, right? It's that upward, like you're rolling a ball up a hill. That slope is positive. Whenever you have a line that looks like it's going downhill, it's negative. Notice this was a vertical line, right? Just like the line in his nose. And right underneath his nose is a U for undefined. It's there to remind us that that vertical line is undefined. And then we have his mouth is horizontal, which is just like this line here. And notice at the end of the mouth, the little dimples, they look like zeros. That's to remind us that the slope of a horizontal line is 0. So he can give us several answers to many equations or questions on our EOC. All right. Start to look at what they're going to ask of us. So they may give us a situation and we have to define, does the situation represent a positive or negative thing? Okay, think about our last test review. We had that notion of a candle. The candle is 18 inches, and as it burned, you burn the candle, it ended up getting smaller over time. So is that a positive or a negative thing? Is that an increasing or a decreasing slope? What kind of slope is it? Positive, negative, undefined, 0? That's what we have to do when we reread these. The length of a bus route increases each day by 2 miles. So there's key terms here, right? Increases every day by 2 miles. There's a rate of change. It's increasing each day by the same amount. So that would be a positive slope. A plane's altitude changes every foot as it approaches the runway. Is that a positive or negative? Think of a plane. If you're in the air in a plane, right, and it's approaching the runway, and the altitude is changing every foot as it approaches. Every foot that you get closer, the altitude is what? Decreasing. So yeah, this would be a negative slope. Joe scores an 80 on every single assignment he turns in. Think of this graph. Here's what your grades, right? Your grades would be over here, and you'd have 1 assignment, 2 assignment, the 3rd assignment, 4th assignment. You have your grades over here, right? The 1st assignment, he scores an 80. The 2nd assignment, he scores an 80. The 3rd assignment, he scores an 80. The 4th assignment, he scores an 80. Is there any change to this? No, this would be a 0 slope. This would form a horizontal line. And then you have what a penny falls straight down off of a roof. There's a house. You have little Somebody's standing on the roof, right? And they drop a penny, and this penny is falling straight to the ground. What kind of slope does that represent? Is it positive? Is it negative? Is it zero? Is it undefined? There's Mr. Slope again. Maybe this time we'll have Grandpa Slope, right? There we go. Little Grandpa Slope. Well, that line doesn't look like this. That line doesn't look like this. That line doesn't look like this. Oh, look, it looks like the nose, which we know is undefined. So be careful, guys, when you're looking at this process that we're doing in this lesson. It's not that it's hard, it's that we need to be very careful. The hardest part is making sure that we know this formula. This is yet now the third formula that we have learned third to fourth formula we've learned in Algebra 1. It must be memorized. You have to know how to use this. They don't give it to you on your end of course exams. It's expected that you know it. If you are practicing it like I've taught you, big division bar, minus, minus. Take any point, the y goes over the x. Take the other point, the other y goes over the other x. Keep, change, change. Keep, change, change. Simplify and reduce. And you'll master this as well. All right. Go ahead, guys, get that homework done. I appreciate all the hard work that you're doing. Have a wonderful afternoon.